Now I'm recording the lecture too. Very good. Okay. So I wanted to do the attendance first, but now let me do that last. And again, make sure to be done with the attendance before going out of the class, and just raise your hand if you have like technical difficulties. So you should be able to answer all your quiz questions. There is just one that has like cycloalkanes, that whether you can just like refer to your book, to answer that. I'm going to cover that on Wednesday, but by looking at your book and reading it, you easily can answer that question too. So I'm not super worried about that one. But again, go through your book examples or like solve problems, and you have like your tutoring tonight, and email me if you. I can send you another reminder if you want on Canvas, so you know the room location and all that. It would be second floor of the library at like 6 p.m. And I have a test bank that I give most of your quiz problems and homework problems. And I gave that to your tutor to solve for students, as a resource. So if you go to tutoring, there is a chance that you see the exact problems in your quiz at tutoring. Because as I said, I designed the questions from that test bank, and then there's high chance that he solved, the same problem, So I really encourage tutoring, and as I told you, basically out of 1,000, I give you, I add 5 points out of 1,000, or 0.5 out of 100, your total grade in this course, just for going to tutoring for each session. So I highly encourage you to go there, and if you cannot go at that session, just email me and I schedule something with you. But I found it really helpful last semester for my Chem 101 course. So, and again, if you have any questions naming compounds, just come to my office hours. We're gonna, learn so many different namings and so many structures. If you have difficulty now, most probably you'll be having difficulty throughout the course. So don't let anything be a question for you. Just So is there anyone that couldn't go through attendance? So I come. Okay. Anyone else?
But you start counting over here, It's always okay.
So I got 4.
We'll figure it out eventually.
Sorry.
Oh no, you should not be sorry. I just realized how early I am. That's
No, I mean, I always want like 10 minutes for my own class. So I totally understand. Okay, so here, and I'm going to have like this slide for some of the sessions, so I make sure that all of you know how to name the alkanes. So what is the first step? It's listed here too. Can repeat with me so I make sure you know?
Find the longest chain.
Exactly. And what is the second one?
Which branch comes first?
Exactly. We want to reach the branch first. So here on the left is the right answer, if you will. On the left is the correct one. In the right is like the one that is wrong. So here we have like more number of carbons. This is correct. This is not. Or here we want to reach the branch first. So if we name from right to left, we have like 1, 2, but here it would be 1, 2, 3. So the structure on the right is not correct, on the left is correct, right? The third thing is that, what is the third thing?
Find the substituent
number
for the branch.
Okay, find the substituents or branches, okay, but what else about the third one? How is it different from the second one?
You want to find it to have the most branches?
Exactly, we want to have more, as much as possible branches. So here, I can name the branch like, I can name the main root like 1, 2, 3, 4, 5, 6. Here it gives me the same 1, 2, 3, 4, 5, 6. So both of them satisfy the first rule, right? The chain is the longest, but this one gives us 2 branches or substituents. This one gives us 1. So the one on the left is correct. Does that make sense? Okay, have a thumbs up. So I assume that's good. What about this one? What is the rule about this? Can anyone remember? Yes?
After you find the branch that's closest to the end, you find the branch that's closest to that.
Exactly. So if you count from both sides, you say, okay, 1, 2, I reach the branch, the second carbon. Here is 1, 2 again. Both of them, they are like equidistance, or like they have the same distance from the branch, however you name them. But you have a third branch. You name it somehow that you start where you are closest to the third branch. So if I name from this side, it would be 1, 2, 3, 4, 5. But if I name from this side, it would be 1, 2, 3. I reach the third branch sooner on the structure on the left. Does that make sense? So this is how we do it. And finally, what is the rule about the last one? Exactly. So if I go from this side, I reach the branch on the carbon number 3. If I go from the right side, also I reach to the branch, to the carbon number 3. So they are I reach the branch the same number of carbons, or carbon number rather. So how do we do that? We name it somehow that we reach ethyl first. So this is ethyl, that is methyl. And can anyone tell me what is the formula of an ethyl? C2H. So what is C2H6? Or rather, let me write it. If you have like CnH2n plus 2, what is the name of these types of hydrocarbons? Alkanes, right? And then when you want to write the alkene, what would you do? You omit a hydrogen, right? So if you have like C2, okay, I became low battery, so I can stop working. So, guess I should switch to cam. Can anyone see this? Okay. This is one of those days. Nothing cooperates with me. Okay, but we keep this going. Okay, can you see this well? Should I adjust it? Is it good enough? Okay, just let me know if it wasn't clear. Okay, so when we have like alkanes, the general structure is CN, H2N plus 2, like C1H4, CH4, methane, right? Or like C2H6, ethane, or like C3H8, propane, right? But when we want to write the alkyl, we omit a hydrogen. So it would be methyl, ethyl, propyl, right? We just like drop a hydrogen and add like alkyl. So alkane became alkyl. And I have a slide about that too, so don't worry about it. But in general, when we have like two carbon, it would be ethyl, right? Because the alkane was ethane and we dropped a hydrogen. And then when we have like one carbon CH3, it has been methane that we dropped a hydrogen, it became methyl. Is that clear? So if you don't know where you should start naming the main branch, start where you have like the lowest letter alphabetically. So instead of starting here, that you reach methyl first, this branch, you start here, that you reach ethyl first, because ethyl is prioritized alphabetically compared to methyl. Is that good? Okay, so that was the review. And also, I kind of have like the screenshot of the book here just to show you, and again emphasize that read the book with me, because I'm just going really slow to make sure that you know how to study with the class, but I cannot finish the book if I just go with this pace. So I need lots of your cooperation to study the book. So here I have like the text for you to also have it in your slides for the ease of reading and all that, and then encourage you to read the book. But it's basically the same thing that I said, Here, like the rules, 1, 2, 3, 4, 5, and the rules. So I'm not going to spend time on these. Basically, these are like, and everything that I write in your explain everything software or the board that I'm using is from your book. If I use anything outside your book, I reference it, so you can refer to that. Okay, any question about this? Okay, so make sure to read the book, both from the slide and then just like go read the book. So now, also we did an example. So can anyone just like grab a piece of paper and pen and without looking at the solution, write the IUPAC name for this structure? And you have like lots of questions in your homework problem. Homework 3, you can just like answer the questions right now. It's just like from whatever I taught you. And as I said, the quiz has like more problems that I'm going to talk about in the class. But make sure to learn this before going home, because all of your homework, most of them are from like naming compounds, and I don't want you not to learn them, okay? So now write this structure and the IUPAC name for this molecular structure, and then ask me when you encounter any difficulty. I just wait for like 1 or 2 minutes. Drink some water. And if you have any questions, just don't be afraid to ask me. These are like things that you should memorize, and just rules that scientists agree that this is how we name the compounds. If you have difficulty, it doesn't mean anything, that. Don't be ashamed or afraid to ask questions. If I didn't know these rules, I wouldn't know how to write this structure either. So don't be afraid to ask questions. Okay, how many of you wrote the name? Okay, can anyone tell me what is the first step?
Longest carbon chain.
Exactly, we find the longest carbon chain, right? So you start counting. If I go this way, it would be 1, 2, 3. Can I find another root that has more carbons?
Yeah.
So what about this one? Good. So this has like the most number of carbons. So should I go in naming, and then we name the carbons in main chain? And something that I realized in the homework problem too, and something that gives the students difficulty. Remember, we name the compound according to the number of carbons in main chain, not the total number of carbons, not the number of carbons in branches, and so on and so forth. So this alkane, how many carbons does it have in the main chain? 5, right? 1, 2, 3, 4, 5. So the name of this compound, what is the main root name, or what is it? Pentane, right? So if you just know this, most of the time, in multiple choice questions, we can just omit 2 answers, most probably, or like at least 1, just by knowing this. So don't get confused. We don't count total number of carbons, just the ones in the main chain. So should I count these carbons from left to right or right to left? Why? Exactly. I reached the branch first. If I count this way, it would be like 1, 2, 3, 4. If I count this way, it would be 1, 2. So this one is the correct one. I say 1, 2, 3, 4, 5. Any questions so far? What is the next step? Yes, I see what branches I have, right? So I have like one here, and I realize that CH4 is methane. If I omit a hydrogen, CH3 would be methyl, right? So I said I have one methyl here, one methyl here. And this is another thing that you should, if you have like, so I have like 2 methyls attached to my carbon number 2. I still should write 2 times because I want to specify I have like 2 methyls on carbon number 2, right? If you had a structure that somehow you had like, I don't know, 3 branches attached to your carbon, you should name the 3 of them, if that's possible. But the point is that you should like name this like 2 and 2. And how many methyls do you have? 2. So we use here dimethyl. So this means that you have like 2 methyls, right? Right? So, and the reason that we write that, because you can have like 1 methyl here, 1 ethyl here, right? So it can be like 2 and 2, ethyl methyl, for instance. So here you should specify that instead of writing methyl, we say dimethyl, right? It's more efficient. And then the name of the alkane. So that would be like 2 and 2, dimethyl pentane. Any question about how we did this? Okay. So let me go quickly to the next example. Again, we went through this in the class last session. So if I just give you this structure, what would be the name? Octane, because we count 1, 2, 3, 4, 5, 6, 7, 8. I have 8 carbons. I have like single bonds. So it's a saturated alkane. And, you can count the hydrogen too, but if you know the rule CnH2n plus 2, you know that is an octane. So this question actually, it gives you, the name of the compound and asks for the structure. So this is like the reverse of what we did. So this is easy. You just like, if you know the rules, you just go reverse. You have like the octane here, so you write octane as it is, right? And then you have like 3 and 3 here. You know that there are like 2 branches attached to your carbon number 3 when you name the carbons. Any questions? And here you have like dimethyl. You have like 2 methyls. So when you have like, when you write the alkane here, you name the you name the carbons 1, 2, 3, 4. And then if you name them the other way around, that's fine as long as you attach them to the carbon number 3, because you were saying like 3 and 3, right? And then carbon number 3 that I just like 3 here, you attach 2 methyls to it, and you check, after you write the structure, you also check, name it without looking at the, this is the good thing about the doc cam, that you can see my hand too if I show something here. Anyway, so here, if you go back here and check, and then you say that, okay, if I want to name this compound, I say, okay, where do I encounter this branch first? If I go this way, it would be like 1, 2, 3, 4, 5, 6. So that's not correct, because here it would be like 1, 2, 3. So I go this way, and then I say 3, 3, and 3 dimethyl octane, because I have 8 carbons. Again, remember, we just count the number of carbons in the main chain, not the total number of carbons. Good? Any questions? Okay. So now let's go through another example. So write expanded, I guess I use my blue, formulas for the following compounds and name them using the IUPAC system. So if you just consider this structure here, or like this abbreviated molecular structure. Remember, the abbreviated molecular structure gives you still the information about how carbons are attached, or like the molecule or atoms are attached in a molecule, but it's kind of like more abbreviated. So it says CH3, and I advise you, when you want to solve these problems, first of all, you see that 1, 2, 3, 4, 5, 6 carbons you have, right? So when you want to write CH3, so I just start with CH3 here, okay? And I have another CH3, but if I put C here, carbon, right? And if I want to attach CH3 here, right? If I write the structure right like this, what is the problem with that?
You only have 2 carbons. You're supposed to have 6.
Exactly. And here, can I attach anything to these hydrogens? No, because they just reach a duet, right? So this structure doesn't work this way. How can I prevent that? So if I write, I should start with CH3, right? But I have CH3 too, and this one didn't work out. So how can I go around that?
Put a carbon branch.
Exactly. The only way that it works out is that I have here I have only carbon, and then attach CH3, as your friend mentioned, just as a branch, right? So this still would be CH3, 2. Is that clear to everyone? Good. Any questions? So now I want to continue. So you see that CH3, 2 is like taken care of. I have 2 CH3, and I have CH. So if I put and remember, usually in these alkane structures and structures that you have like a chain of carbons. You cannot have C, C, H, C, H, C, because hydrogen can only have 1 electron, and when it forms bonds, maximum can have 2 electrons, so it cannot be in the middle of a chain, right? Because in that way it would have 4 electrons, and that's not correct. Okay, so CH3, 2, so is this, and then CH, it would be this one, right? And then you check that carbon has 4 bonds, and it has 8 electrons in total when it's shared, so that's taken care of, right? And hydrogen have 2, and then so this CH is also taken care of, and then we have CH2, and then again we have CH2 and CH3. So this is how we write from abbreviated molecular structure the complete, or expanded chemical structure for this molecule. Any question about that? So when you want to write the expanded chemical structure, remember, hydrogen can maximum form one single bond, or can have maximum 2 electrons. Carbon can have like maximum 4 chemical bonds, in this case like covalent bonds, or like maximum 8 electrons. It reaches an octet, right? So if you know that, you can check and then write. And as we said, these abbreviated chemical or molecular structures, they tell you, that you have like CH3 next to each other, or like close enough to each other. So it guides you how to write the expanded chemical formulas. Good? So now we want to name this. How do I name this? What is the first step? Yes, finding the longest carbon chain. So if I go this way, how many is it? So it's too low, right? If I go like, how else? This, like this. How many would that be? Yes, or what about this one? And you just make sure that you have like the most number of branches. So in these two structures, both of them give you the same number of branches, right? So you're welcome to choose any of them. I just go with the straight line because it's more straightforward. And I write, like, when I want to name the carbons, should I go left to right or right to left?
Left to right.
Why?
You encounter the substituent first from
Ex-
left to right.
exactly.
Fastest, I guess.
Yeah, exactly. We encounter the substituent first. So we go from left to right. And I write 1, 2, 3, 4, 5. First of all, what would be the root name or like the main name of this compound? What is it? Because we have like 5 carbons in our main chain. So you can just write this from the beginning. And what is the number of carbon number that has a branch or substituents to it? So I write 2, and then we use a dash, right? And what is this substituent here? Exactly, methyl or CH3. So 2, methyl pentane. Are we getting comfortable with naming?
Yeah.
Are we getting too comfortable, getting too boring? Okay. So now I'm going to actually start with the lecture. And now we're studying section 2.4. And as I said, I cannot emphasize you guys enough to read the chapter, and I made the textbook mandatory for a reason, Anyway, so right now, we talked about alkyl substituents. And now I'm going to review those and also talk about halogen substituents. So in general, as we said, if I have like ethane, you can write it like C2H6, or you can have like the, abbreviated chemical structure. So if you have like ethane, if you write the structure, would be C2H6, and then if I want to abbreviate this one, I say CH3. So I know how the atoms bond together. Remember? Okay. So here, if I omit one of the hydrogens here, and I write CH2, CH3, CH2. So for writing alkyls, we omit a hydrogen. I think I had a dream that someone told me to write, better, like have a better handwriting. So I don't think it happened in real life, so probably it was a dream. So for writing, just like reminding myself. Usually I'm just rushing to go through the materials and just like write, fast, and then I forget that how bad it may look. Just, let me know if you couldn't read something, just don't give up on me. So for writing all alkyls, we omit a hydrogen from corresponding alkane. So C2H6 would be C2H5. And here we have like the abbreviated chemical structure, molecular structure. So if, we omit one hydrogen here, it will be CH3CH2 or C2H5, or we just write it ET, So it would be ethyl group, not the alien ET, just like ethyl. Sometimes I try to make jokes, sometimes they just be so cheesy, but sometimes maybe they would be better. I don't know. Anyway, when we come to propane, there are two possible alkyl groups, because if I have and I have it in the next slide, or maybe, and then going back here, there are two possible alkyl groups depending on which type of hydrogen is removed. And I asked you this in your homework problems, that how do we name different alkyls of derived from propane? So and I said, depending on the carbon that is removed, depending on the hydrogen that is removed, depending on the type of the chemical bond that they have, and all sorts of things, So remember that is based on the type of hydrogen that is removed. And then if a terminal hydrogen is removed, the group is called a propyl group. Let me go here. And as I said, I'm going to post everything online, so don't worry about if you're writing and I go to the next slide. So I'm going to go back to that too. So what is propane? Exactly, because with the 2N plus 2, right? C3H8. And then if I write the expanded molecular structure, it would be like 3 carbons, and then I have like hydrogens all around it, right? So now I can whether omit to write the corresponding alkyl. I can omit the hydrogen here, right? Or I can omit the hydrogen here. And depending on which hydrogen I omit, I will be having like 2 isomers of this alkyl. Remember what was isomer? An isomer?
It has like the same number of atoms, but in different arrangements.
Exactly. They have like the same molecular structure, molecular formula, but different molecular structures, right? So here, the formula for both of them, for propyl, or what would that be? So propane is like C3H8. What is propyl?
C3H7.
Exactly. And then can anyone count these atoms here and tell me what is this molecular formula?
C3H7.
Right? Both of them are like C3H7, but in one of them, the molecular structure is like this. This hydrogen here is missing. For the other one, this hydrogen here is missing. Or like we omitted that hydrogen from the corresponding alkane, from propane, right? So they have like the same molecular formula, but different molecular structures. So this one we call propyl. This one we call isopropyl. And you should just like remember the name. But is this clear now how we did this? And for some reason it just keeps switching to eraser. Okay. If a hydrogen is removed from the central carbon atom, we get a different isomeric propyl group called the isopropyl or 1-methyl ethyl. And the methyl ethyl is based on how we agree to, name compounds based on the IUPAC, right? So here, if I have like this, or like, you have like, if you, here you have like methyl, and then because methyl is CH3, right? What is ethyl?
C2H6.
So let me write. I want to write ethyl, right? So what is ethane? So this is ethane. So if I remove a hydrogen, I reach ethyl, right? So what is ethyl? So this is ethyl. So here, methyl ethyl. C2. So this is methyl. This is one. I kind of confused myself. So isopropyl is like 1-methyl ethyl. And if I want to name, let me have write this here. Okay. And I don't have a hydrogen here, right? And if I consider this, okay, so I have what is it? One. So to this carbon, we have a methyl group and an ethyl group. Let me check if I write this. Right, I'm pretty sure I did. CH3. Okay, propyl, methyl ethyl. Okay, let me just show you the book. And hopefully this is still recording. Okay, so here we have let me go back here. So we have the propyl group here, the thing that I just talked about. And then here, if we remove this hydrogen here, we'll be having CH3, CH3, or IPR. So it's isopropyl or 1. And then we say 1 because to this carbon, we have an ethyl group. And then it says the name 1-methyl ethyl for this group comes about by reading it as a substituted ethyl group. So CH3, CH2, here we call this, C2H5 is ethyl. And then here we have a methyl group, right? And then to the carbon number 1, we have methyl and ethyl attached to it. I guess this is how we agree to name this. But as long as you know isopropyl, you're good. Does that make sense? Did anyone got confused like myself? We're back to recording. Hopefully it's good. Then now we have butyl. That it also have more configurations. So now instead of having 2 different isomers, we have 4, because for butane so what is butane first of all? C4, right? Exactly. And then if we write the structure, it would be like this, right? The hydrogens here. And again, depending on what hydrogen we remove, we have like different names. So one of them is like, you know, butyl itself. The other is like sec butyl, which is, slides are basically the same. This one just has a, if I go back here, if we remove the hydrogen here, we call it butyl, right? If we remove the hydrogen from here, second carbon, we call it like sec butyl or like 1-methyl propyl here. And I think the thing that I got confused because I didn't have the hydrogen here, you know, and it was like, I got confused because it wasn't exactly like C3H7. You know what I mean? Because we removed this hydrogen, but you name it as if we had like the hydrogen, if that makes sense, you know. So 1-methyl propyl is the other name of sec butyl. And then here, if I remove, I guess I change this to indigo. So if I remove the hydrogen from, you know, the third carbon, we have like the third butyl, or like we have like, you see, so CH3, CH3, CH3 here, and here for like isobutyl or like 2-methyl propyl, and then you can just like write the structures for each of these like here, and then reach them from the, you know, butane itself. So if you do that for that, it would be like, you know, so here is iso. So here's the tricky part. So butane itself has an isomer. So we get like these two first structures from butane itself. We get the second two from like isobutane. So one structure for butane is like this one that I just wrote here. The other one is like this. And then you attach hydrogens, right? So butane itself has an isomer. So this is like CH3, and then this is like this carbon, and then this is this CH3, this is this CH3. So if we write the ethyl, or like, sorry, alkyl from like butane, it would be butyl and sec butyl. But if we write them from like isobutane, it would be isobutyl and third butyl. Does that make sense? Any questions? So remember, butane itself has an isomer, and for that matter, these two structures cannot be derived from this one. They derive from this one, isobutane. Any questions? Okay, abbreviated for like second. Here we have like, you know, hydrogen removed from the secondary carbon, or like tertiary carbon. If we remove the hydrogen from that, we call it like third butyl, right? And I think these two bigger font. So this is kind of like what I just said. And in general, when we want to depict an alkyl group, we depict it with an R. So that is like the abbreviation of like an alkyl group. So if I have like RH, it means that I have an alkane, and if we have like RCl, it means that we have like alkyl chloride. So all the structures that we talked about so far, they only have like, you know, methyl groups. They only had like carbon and hydrogens. It's possible we also have halogens in our hydrocarbon, right? So this is how, you know, if we have like, you know, alkanes, we have like, you know, alkyl groups, you know, plus hydrogen, right? So remember when I said that, how do we write alkyl? We said that we have an alkane and then we remove a hydrogen, right? So the reverse is also correct. If you have like alkyl attached to a hydrogen, that represents an alkane. Is that clear? So now we can have an alkyl, and instead of hydrogen, it attaches to a halogen, right? So instead of RH, it would be like RCl or Br and so on and so forth. So this is how we name them. We say, alkyl chloride. So we have like the base name of the nonmetal plus IDE. So we have like methyl chloride, ethyl chloride, and so on. Is that clear? As long as you learn the rule, the rest is just like remember that. As I said, you have like lots of definitions, lots of things to remember. So if you have halogen substituents are named by changing the I-N-E ending of the element to, O. So fluorine becomes like fluoro, I guess. Cl would be chloro, and then bromo, iodo, right? And again, these things are just things to remember. These are rules that, chemists just came up with. So let's do an example. So if I tell you that give the common and IUPAC name. So here I'm just asking for like the IUPAC name. So if I ask you that what is the IUPAC name for this compound here? So what you do first, convert the abbreviated chemical structure to the expanded one, because you want to name the carbons, you want to find branches. Here it's like difficult to find that. So what you do, you write like CH3 and then CH2 Br. Is that clear? Good. Any questions? So now we want to find the longest chain of carbons. There's just one possibility, right? So we name it somehow that we're like, remember, this is also, kind of like your branch. We name it somehow that we are like closer to Br, right? So we say 1, 2, 3. So we say 1 bromo, 1 dash bromo. Remember, we said just we add O instead of fluorine, instead of INE, we add O. 1 bromo propane, again, because our main chain has like 3 carbons, right? And then the common name, of the alkyl group is by the name of the halide. Anyway. So here I have like an example that I don't have to go through it, but I have also there, so I encourage you to go through that, and we still have the attendance, so bear with me. So go through these examples, answer listed here, and email me if you have any questions, And I have also,